Hey, geometry kids. This is the start of chapter 10. We made it through that trig. Hopefully circles will go a little bit easier for you if you struggle with the last one. Make sure you don't spend too much time on the trig and get into chapter 10 here a little bit and work on these circles. And then we have volume and surface area, and that will be it. So chapters are a little bit longer, about 6-7 lessons each, but we'll take our moments to get through there. If you wanted some extra practice, those of you who needed something to do, page 277, here are the answers. There's the top, and there's the bottom. So the bottom is completing the square. That's the blankety blanks for those in Algebra 2 last year. You take half of 6 and square it, and that's what goes in the blanks. Factor, simplify, square root both sides, and solve. Okay. Top is just a double distribution or FOIL. Okay, so chapter 10. What are the definitions of the lines and segments that intersect a circle? These are the units that we're got to be able to recognize. Diameter, of course, goes all the way through. A radius goes from the center to a point outside. A tangent has one point of intersection. Where a secant has 2 points of intersection. They're both lines. Tangent has 1 point, secants have 2 points, and those are both lines. So the arrows, they go on forever. Tangents will always be perpendicular to a radius. So perpendicular to a radius or a diameter. Okay. A chord has 2 endpoints on the circle. So diameter could be considered a fancy chord, but we just call it diameter. So a chord has 2 endpoints on the circle. Okay, so those are the terminologies, being able to recognize those. Lots of, page 280, lots of definitions. Please take the time to fill in those. Write them down, know what you're needing, know what you're getting into with this. Some of this stuff down here will be a little bit new. A lot of it should be familiar for you. Okay, so here are a lot of those definitions. You can take and copy those down. So a diameter is a chord that contains the center of the circle. So diameter is considered a chord. It's like a square is a fancy parallelogram, that sort of thing. Secant is a line that intersects a circle in 2 points. Tangent is that intersects the circle in exactly 1 point, and you have a point of tangency. Okay, that would be point B, is a point of tangency. Coplanar. Coplanar means you're in the same plane. Circles and common tangents. Okay, and I have some more examples that I've drawn down here. We'll have to go beyond the book a little bit to get some practice. Okay, so in a plane, 2 circles can intersect in 2 points, 1 point, or no points. Coplanar circles that intersect in 1 point are called tangent circles. So that's what we have here. You have coplanar circles, they're intersecting at 1 point. Those would be called tangent circles. Okay, this right here is a concentric circle. They have a common center. Okay, so you think of a bullseye. Those are concentric circles. Okay. This next part, a line or segment that is tangent to 2 coplanar circles, is called a common tangent. So if it's tangent to 2 circles, it's a common tangent. And then you have internal tangents and you have external tangents. Okay, and how you determine internal from external is the segment that joins the center of the 2 circles. If it crosses that, it's internal. If it does not cross that, then it's external. So if it crosses, so when I look at this right here, how many common tangents do we have? So I have 2 circles, they're spread out like that. Well, you're going to have these 2 out here, 1, 2. Those are 2 common tangents. And then you also have 2 that are in here. 1, 2. So this one, we actually have 4 common tangents here. But the question is, are they internal or external? So if I draw this line right here connecting the centers, so a segment that joins the centers of the 2 circles. So this segment joins the centers of the 2 circles. So the green lines would be internal, because they cross that segment. So those would be internal, and the red lines would be external. So these red lines are external common tangents, and the green lines would be internal common tangents. Okay. So these would be tangent circles. They have one line of tangency right there. They just have one. Is it internal or external? Well, you look at the segment that joins the circles and you see how the tangent crosses that, making this an internal common tangent. Some special situations here: if you have a circle inside a circle or concentric circles, there are no points of tangency. There are 0 tangents. Okay, there's no way to get a line. It has to be a full line that touches it twice. But if you have part of the circle outside, then you do have those points of tangency right there and right there. And those would be external because here's your segment that joins the centers, and it does not touch the segment. Remember, that is a segment, that is not a line, so you do not extend that path. So those would be external in that case. Okay. So use the diagram, name 2 radii. So 2 radii. Radii go from the center out. So center out. So you actually have 3 options: AD, AB, and AF. AB, AD, AF. Okay. Name a chord. Well, we could do ED. That'd be a chord. We could do EC. That'd be another chord. Or a fancy chord would be actually the diameter, DF. You could do DF all the way across. Name a diameter, DF. Has to be that one, the only one shown. Okay. Name a secant. A secant has to go through the line. It is a line, so ED with a line segment on top. Has to be a line segment. These will all be multiple select, multiple choice. You do not have to type these in, so don't worry about your fancy symbols of line on top. So that makes it easy for you. That is the only secant. This is not a secant because it only has one point of intersection right there. So name a tangent. They did not give us. We'll name a point there. Let's say so. BG. We'll name that point. I drew that myself. So BG, it's a line that is a tangent, BGs, EBGBs. Name a point of tangency, that would be point B. And if this is tangent, then we know this angle has to be a right angle. Okay? We'll see that coming up here in a little bit. So tell how many common tangents the circles have and draw them. So these are overlapping circles, 2 points of intersection. That means we have 2 tangents like that. You could try to draw another one, but it would not work anywhere. So 2 common tangents, and are they internal or external? So I draw this segment connecting the centers. These do not cross that segment, so these are external. So this has 2 external common tangents. Okay. Okay. Point D is a point of tangency. So if that's a point of tangency, we have a 90-degree angle here. Find BD. So you notice the Pythagorean, the right triangle. Okay, so we have 5.5, we have 10. 10 is the hypotenuse. So a squared plus b squared equals c squared. The hypotenuse is known. So a squared plus 5.5 squared equals 10 squared. So a squared equals 10 squared minus 5.5 squared. So a is the square root of 10 squared minus 5.5 squared. Calculator. Okay. So square root of 10 squared minus 5.5 squared. That weird answer. About 8.35. 8.35. Okay, that's what we get from that. Using Pythagorean theorem. Point C is also a point of tangency. Okay, this is going to get fancy. I'm going to go through this one. I don't think you have any questions at this level, but those who are interested, you can do it. Point C is also a point of tangency. If BC, let's see here. I haven't done this one yet. So 4x plus 6. Find the value of x to the nearest tenth. Oh, this one's not bad. So BC and BD, that'd be 5.5 as well, that radius, because that radius is 5.5, which means BC has to equal BD. Well, we know BD is 8.35, BC is 4x plus 6, so if I solve for x, so if I minus the 6, divide by 4, we get 0.6. 0.6, that's the value of x. That's not the length of that segment, that's the value of x. So if you have common tangents that intersect, the distance from that point to the point of tangencies will be congruent on either side. Okay, you will have questions like this. Tell whether CD is tangent to circle A. So they give you enough information here. And it's all dependent on whether it's a right triangle or not. Okay, so is ACD a right triangle? So we're going to use Pythagorean theorem. Does 8 squared plus 14 squared equal 17 squared? Remember, oh, I wrote that wrong. That should be 17. That should be 14. Okay, this is the right angle. This needs to be the hypotenuse. So that means it's the C value. So A and B can be either one, but this has to be the C value. So does 8 squared plus 14 squared equal 17 squared? Well, that's 64 plus 196, and that is 289. Well, 64 plus 196 is 260. That is not equal to 289. So the answer is no. Triangle ACD is not a right triangle. Okay, so all those questions there, you need to check your Pythagorean theorem. Does a squared plus b squared equal c squared? If it doesn't, then it's not a right triangle. So those are these questions here. Tell whether it's tangent. Check a squared plus b squared equals c squared. Hypotenuse has to be c. And then either is a right triangle or it's not a right triangle. And that should be it. Let me know what questions you have. Good luck and happy circling. See you later. Miss you all.